Hi, Astro Liz's lab. My name is Eva Pettinato, and I work at Masten Space Systems. I'm a lead guidance, navigation, and control engineer for Masten's lunar lander. I get to do everything involved with getting the spacecraft to know where it is, where it's going, and how it needs to get there. I lead a team of 8 engineers here at Masten. One of the things I love most about working at Masten is how Masten's mission and vision aligns with my own. Masten's mission is to accelerate the realization of space ecosystems on the Moon, Mars, and beyond. And I am so excited to help with that. The coolest thing for me about being a GNC engineer is how involved I get to be in the spacecraft design. I get to choose sensors that tell the spacecraft where it is, like inertial measurement units, star trackers, and terrain relative navigation systems. Terrain relative navigation systems actually take pictures of the moon and compare it to maps to help it figure out where it is. This is called navigation. Navigation feeds into guidance. Guidance is where the spacecraft plots the course to where it needs to go. It can do this either automatically or with help from the ground. Controls is what helps the spacecraft get there. The calculations here help determine what parts of the spacecraft need to move to get there. On our lunar lander, we have 6 large main engines and 12 small RCS thrusters. The control algorithm figures out which valves need to open or close to help us get there. We code all of this up, and then we run simulations so we can analyze everything. We code up models of everything that we know the spacecraft will experience and everything the spacecraft has. We model gravity, all the motors, how the mass of the spacecraft is changing, and so much more. Then we run something called Monte Carlo simulations, which help us figure out what might happen if something is a little bit off. Everything that we model has some amount of uncertainty because some things we can't measure as well as we would like. So we run these simulations to cover all of that uncertainty so that we can make sure everything will work the way we want, even if we're a little bit wrong. Spacecraft are very expensive, so it's good to make sure that they work when things go wrong. After all of that analysis, we get to test stuff. We turn everything on, we make sure that everything is happening the way we actually think it will. And this is one of my favorite parts because we actually get to see everything work. We run all of our code and then we visually see what happens. Okay, I lied about the last part being my favorite part. A really, really amazing part of being a GNC engineer is getting to be in the launch control room when it's showtime. It had always been my dream for such a long time to get to be in a launch control room, and I've already done it twice. If you're interested in being a GNC engineer, pay close attention in math class and physics. You don't have to be perfect at it. We have computers to help us with a lot of it. Even if you're not so great at some of the math, you can still be a GNC engineer, but you should at least kind of like it. And then when you go to college, you should major in aerospace engineering. I majored in astronautical aerospace engineering, so I learned all about space and spacecraft dynamics when I was going to school. And then I even got a master's degree in aerospace engineering as well, because I couldn't get enough of it. But even if you just get through a bachelor's degree, you can still do it. If you're interested in learning more about what I do on a day-to-day basis, you should check out Masten's website at masten.aero. And if you want a little bit more of a personal insight into really my day-to-day life, you can check out my Instagram at First Coffee, Then Rockets. It was great talking to you today, Astro Liz's lab. See you next time.